Good morning to all. Myself, Sajini John. In the previous classes, we have learned about matrices. What is a matrix? Elements of a matrix and order of a matrix. Then different types of matrices. Then addition of two matrices. Addition of two or more and subtraction of two matrices. Then multiplication of a matrix by a scalar. All these things we already covered. Today we are going to learn about multiplication of two matrices. And first we can check how can we multiply two matrices. Before that, multiplication of two matrices are possible only when the number of columns in the first matrix is equal to the number of rows of the second matrix. When we are doing problems, you can understand it. Now we can do one simple question. Okay. Now, look, we can consider two matrices A and B. You can see the elements of matrix A are 2, 5, 3, 1. In B, 3, 0, 4, 6. Now, you can see the order of first matrix is 2 by 2 and order of second matrix also 2 by 2. And here we can see the number of columns in the first matrix, that is this 2. Okay. Number of columns in the first matrix is equal to the number of rows in the second matrix. Therefore, we can see the multiplication of A and B is possible. Now, we can find how we can multiply these two matrices. For that, we can write these two matrices together like this. The rule is, I will tell you the rule. First step, multiply every element of the first row of matrix A with the corresponding element of first column of B and add them to get the first element of the first row of the product AB. I will explain it. The first element. First we are going to find the first element of the resulting matrix. For that, consider first row of the first matrix and first column of the second matrix. We can draw two arrow marks like this. Okay. And multiply like this. The corresponding elements 2 into 3 and 5 into 4. Multiply these two and add. Look, 2 into 3 plus 5 into 4. That is the first element in the first row. Okay. Then second element is like this. First row itself, multiplication by first row and second column. First row of the first matrix and second column of the second matrix. You can see here, look, this is the second element. This and this, then add like this. You can see when we simplify the first one, 2 into 3 plus 5 into 4, we will get 26. We can write that element here. And next is 2 into 0 plus 5 into 6. What is 2 into 0 plus 5 into 6? It is 30. 2 into 0 is 0, 5 into 6, 30. So we get two elements. So first row completed. No more columns here. Okay. Then next, two more elements. We need 2 more elements. For that, the same process, like 3 into 3, that is the second row of the first matrix by first column of the second matrix, that is 3 into 3 plus 1 into 4. Here we get the third element, 3 into 3 plus 1 into 4. We get that value 13. And next is 3 into 0 plus 1 into 6. That element is 6. This is the steps of multiplication of two matrices. Now we can check what is B into A. Here we found A into B. The result is 26, 30, 13, 6. Now we can see what is B into A. For that, look here. B into A. Write the matrix B first. Second matrix A. And we can draw this arrow mark. Now, because we are putting this arrow mark, we are multiplying in this way. That's why. For easiness, that's all. Now, you can see first element. We can see what is first element. 3 into 2 plus 0 into 3. That is the first element. Second element is the same row. We are considering the same row. 3 into 5 plus 0 into 1. Here. Then 4 into 2. Next row. We are considering next row, and here we are writing the answer in the next row. 4 into 2. Okay, 4 into 2 plus 6 into 3. That is the next element. And last one, 4 into 5 plus 6 into 1. Okay. Now you can simplify this, all this. You will get the result 6, 15, 26, 26. So B into A, the elements in B into A are 6, 15, 26, 26. But what was A into B? The elements are 26, 30, 13, 6. Here we can conclude in matrix multiplication AB is not equal to BA. Okay. In numbers, if we consider two numbers, 3 into 5. 3 into 5 is 15. And 5 into 3 also 15. Okay. That is, multiplication of numbers is commutative. That law is known as commutative law. So, the multiplication of numbers is commutative, but here in matrix multiplication is not commutative because AB is not equal to BA. Okay. Now we can see the order of the resulting matrix. It is very easy to find the order of the resulting matrix. I'll give some examples. Look here. Suppose order of matrix A is 2 by 3 and order of matrix B is 3 by 3. And I told you matrix multiplication is possible only when number of columns in the first matrix is equal to the number of rows of the second matrix. Here we can see these two are same. And the order of the resulting matrix is the remaining part, 2 by 3. You can see 2 by 3. You can see many examples here. Look, P and Q. These two same. Then only multiplication of PQ is possible. 3 and 3 same. And the order of the resulting matrix PQ is 4 by 2. Similarly, you can find the order of these matrices, the resulting matrices Mn. It is obviously 2 by 1, and here AB is 3 by 2 and CD is 2 by 3. And we can generalize this rule. That is, suppose order of matrix A is M by N and order of matrix B is N by P. N and N same. Therefore, order of the resulting matrix is M by P. Okay, in this way we can generalize. Now we can see one question. Evaluate if possible. You can see this two matrices are there. 3, 2, first matrix, second matrix, 2, 0. First we can check whether the multiplication is possible or not. For that, write the order of the first matrix, that is 1 by 2, 1 row and 2 columns. Second order of second matrix is 2 rows and 1 column. So 2 by 1. These two are same, 2, 2. Therefore, it is possible for multiplication. And we can find the order of the resulting matrix also. That is 1 by 1. That means only one element. So multiply. First, only one element. That element is 3 into 2 plus 2 into 0. 3 into 2 plus 2 into 0. The result is 6. Similarly, another question. Question is, first matrix you can see 1 minus 2 elements. The other one minus 2, 3, minus 1, 4. You can check whether multiplication is possible or not. Order of the first matrix is 1 by 2. Order of the second matrix is 2 by 2. So you can see it is possible because here 2, here also 2. Order of the resulting matrix is 1 by 2. Okay. Anyway, we can multiply these two. So for that, first row into first column. So 1 into minus 2 plus minus 2 into minus 1. That is the first element. Next, one more column is there. So 1 into 3 plus minus 2 into 4. That is the second element. When you solve this, you will get here minus 2 into 1, minus 2. Plus 2, that is 0. Here 1 into 3, 3. 3 plus 8, minus 8. 3 plus minus 8, that is minus 5. So, this is the answer. Now we can see one more question. Actually, it is homework anyway. Look here, I will explain. You can see 3 matrices are there. I is the unit matrix, A, B and I. Now the question is find AB. As usual, we can find AB. Write A first, then B. That is 0 into 1 plus 2 into 3, first element. 0 into minus 1 plus 2 into 2, second element. 5 into 1 plus minus 2 into 3, third element. 5 into minus 1 plus minus 2 into 2, that is the fourth element. In this way we get 4 elements. And when you simplify this, you will get the result. Okay. Similarly, you can find BA, AI. When you multiply A and I, you can see the result is A itself, 0, 2, 5, minus 2. At the same time, I into A also A. When you do, you will get that. And next is IB. IB is B itself. You will get it when you multiply in the same process, the help of the steps. Now, A square. Next, A square. For finding A square, write A 2 times A and A. And you can put arrow marks and multiply. You will get the result. When you multiply, as usual, 0 into 0 plus 5 into 2, that is 10. Okay. By using mental work, we will get the result. 0 into 2, 0, plus 2 into minus 2, minus 4. Like this, you will get the result. Now next is b square. B square also b into b. When you multiply these two, you will get the result. One more question. Question number 3. If a is equal to 3x01, b is equal to 9, 16, 0 minus y. Find x and y if the condition is given if a square is equal to b. The condition is a square is equal to b. So, first we can find what is a square. Then, after that, equate that a square by b. First we can find what is a square. So, write a square. A into a. You can see this. A into a. 3x01, that is a. This is also a. 3x01. Multiply this. You can put this arrow mark. Okay. 3 into 3, 9. Plus x into 0, zeros. Therefore, only 9. Next is 3 into 3 plus. Next is 3 into x plus x into 1. That is 3x plus x. That is 4x. Next is 0 into 3, 0. Plus 1 into 0, again 0. 0 into x, 0. 1 into 1, 1. In this way, we can find what is a square. And we can consider the given condition. A square is equal to b. Now, we can write a, since a square is equal to b, equate these two. That is 9, 4x, 0, 1. That is a square. B is 9, 16, 0, minus 4. Already given in the question. Now you can see two equal matrices. Therefore, we can equate. That is 9 in the place. Corresponding element is 9. Because equal matrices are there. Now you can see 4x is equal to 16. Next we can write 4x is equal to 16, which implies x is equal to 4. Here 0, 0. 1 is equal to minus y. 1 is equal to minus y, which implies y is equal to 1. Therefore, we get the values x is equal to 4 and y is equal to minus 1. Now, another one. Find x and y. Same type of question. You can see this. 4, 3x, x minus 2. One matrix. Multiplied by another matrix 5, 1, which is equal to y, 8. So, as usual, we can multiply these two matrices. 4 into 5 plus 3x into 1. That is the first element. So, first row over. Now, we can take second row. So, result, second row. X into 5, 5x. Plus minus 2 into 1, minus 2. So, 5x minus 2 is equal to y and 8. That already given. Therefore, you can write. You can see two equal matrices are here. Therefore, 20 plus 3x is equal to y. At the same time, 5x minus 2 is 8. From the second one, 5x minus 2 is equal to 8. You can write 5x is equal to 10. And x is equal to 2. And here you can substitute the value of x in the first equation. Here you can say this is first equation, this is second equation. Now substitute that value here, you will get y is equal to 26. When we substitute 2 here, you can see 2 here, 3 into 2, 6. 6 into plus 20, that is 26. Okay. Now, we can go to the next question. Look here. Two matrices are given. Three matrices are given. A, B and C. Three matrices you can see. And find AB into C is equal to A into BC. Find these two. Then after that we can check whether they are equal or not. First, for finding AB into C. AB is in bracket, so multiply AB first. When you multiply AB, you will get this result. 13, 11, 18 and 16. Then multiply this AB by C, the last one. So, AB into this C. Multiply these two. You will get the result 63, 61, 88, 86. Multiply by yourself. You will get this result. And next is A into BC. First we can find what is BC. So write BC, B into C, this matrix and this one. You can put this arrow marks. Then multiply this. The result is 6, 7, 19, 18. Then we want to find A into BC. First matrix A. So substitute A first. A into BC. BC is this. Multiply, you will get the same result. You can see AB into C. Order is same. AB into C is equal to A into BC. Okay, so these two are same. When you do, you can find these two are same. Now next question, question number 7. If A is equal to 1, 1, 0, minus 2, B is 4, 1, minus 3, 2, C is minus 3, 2, minus 1, 4. Find A square plus AC minus 5B. This type of questions are important. I think it's a board question. And first you have to find what is A square. That is A into A. As usual, you can find A square. Now, write A and A together. 2 into 2 plus 1 into 0, that is 4. 2 into 1 plus 1 into minus 2, that is 0. 0 into 2 plus minus 2 into 0, that is 0. 0 into 1 plus minus 2 into minus 2, that is 4. In this way, we get A square. Next, you have to find AC. Write A and C together. You can see A and C. Multiply these two, you will get minus 7, 8, 2, minus 8. Then next 5B. So we can write 5B also. Multiplication of a matrix by a scalar 5B. Multiply each element by 5. You will get 25, minus 15 and 10. This one. Now you can write this expression A square plus AC minus 5B. Write that expression A square plus AC minus 5B. We know all these values A square, AC and 5B. So write this in the same order. And corresponding elements solve. 4 plus minus 7 minus 20, that is minus 23. 0 plus 8 minus 5, that is 3. 0 plus 2 minus 50, that is 17. Next is 4 plus minus 8 minus 12, that is minus 14. These are the elements in the resulting matrix. Now, we can see, now question number 12. B is equal to 2101 and B square is equal to b plus half of a. Find a. First we can transpose b to the left side. Then we get half of a is equal to b square minus b. Okay. So first we can find what is b square. Can see the steps. Half of a is equal to b square minus b. So first to find b square. 2, 1, 0, 1, 2, 1, 0, 1. Multiply these two, you will get 4, 3, 0 and 1. When you multiply, then we can apply this. Half of a is equal to b square. This is b square minus b. b square, this is b square minus b. b is here, you can see. When you subtract this from the first, you will get 2, 2, 0, 0. Therefore, a is equal to, transpose 2 to the other side, you will get what is a. Okay, one more there. Question number 16. It is given 2x plus 5y, that is the first element, 5x plus 2y, second element, which is equal to minus 7 and 14. Solve this. We know 2x plus 5y is equal to minus 7 and 5x plus 2y is equal to 14. And you can see two simultaneous equations. You already studied how to solve a simultaneous equation. And three different methods you have learned. You can use any one here. When you solve this, you will get the result. Next is question number 17. In each case given below, find the order of matrix M. Order of matrix M and then find the matrix M. It is given M into 1, 1, 0, 2 is equal to 1, 2. Now we can consider, let the order of matrix M be A by B. A by B. Order B, A by B. So here we can write order of matrix M. And we can find the order of the second given matrix, that is 2 by 2. Then the resulting matrix order is also only one row and two columns. So 1 by 2. Write this. And here you can see multiplication of two matrices is possible only when these two are equal. Therefore, we can find B is equal to 2. And we know the order of the resulting matrix is A by 2. So, under this we can write A by 2. Therefore, what is A? From here we can see A is 1 and B is 2. B is 2 and A is 1. Therefore, order of matrix M is 1 by 2. Okay. Order of matrix is 1 by 2. That means only one row and two columns. Order is 1 by 2. One row and two columns. Therefore, we can write let M is equal to 1 row and two columns. Therefore, let it be X, Y. Again, here we can substitute that value. M is XY and this we get 1, 2. Okay. So, we can write X, Y into the given matrix 1, 1, 0, 2 is equal to 1, 2. Multiply this. Left side we get the first element is x into 1 x plus y into 0 0. Therefore, x only. Next element x into 1 x plus y into 2 2y. The result is 1, 2. From here we can write x is equal to 1 and x plus 2y equal to 2. X is equal to 1. Substitute that value here. You will get 2y is equal to x is 1. So 2 minus 1, that is 1. Therefore, which implies y is equal to 1 by 2. So x is equal to 1 and y is equal to 1 by 2. Therefore, what is matrix M? 1 and 1 by 2. Two elements. 1 and 1 by 2. These are the elements in matrix. Now we can see one more question from this part. Question number 25. If A is equal to 2, 1, 1, 3 and B is equal to 3 minus 11, find the matrix X such that AX is equal to B. The condition is AX is equal to B. Okay. Matrix A is given and matrix B is also given. Now we can start. Let order of matrix X be M by N. So we can write this. Order of matrix A 2 by 2. Matrix X M by N. B 2 by 1. Therefore, from here you can find what is M and N. Here you can see M is equal to 2 and here the resulting is 2 by N. Here we can write 2 by N. Therefore, N is equal to 1. Therefore, we can write order of matrix X is, since M is 2 and N is 1, order is 2 by 1. That means 2 rows and only 1 column. Therefore, we can assume X matrix S X as A, B. Now, you can see this is A and this is matrix X, this is B, because A into X is equal to B. That is already given. Now multiply left side, you will get 2 into A plus 1 into B. That is the first element in the first row. Then this 1 into A, that is A, plus 3 into B, that is 3B, which is equal to 3 minus 11. Now we can write the corresponding elements are equal. 2A plus B is equal to 3 and A plus 3B is equal to minus 11. You can see two simultaneous equations, and when you solve these two simultaneous equations, you will get the result A is equal to 4 and B is equal to minus 3. Then we can write X as, X is equal to 2A plus B is equal to 3 and A plus 3B is equal to minus 11. When you solve this, you will get the result A is equal to 4 and B is equal to minus 5. You can solve these two simultaneous equations by yourself. You can do it. Therefore, today we can wind up our class, and we learned how two matrices can be multiplied and what is the compatibility of multiplication of two matrices. Okay, so bye.